Hi, I am Arslan Tirsi. I am an electrical and electronics engineering student at İzmir Katip Çelebi University in Turkey. Today, I will present to you my work, Conveyor Belt Speed Control with PID controller using two PLCs and LabVIEW based on OPC and Modbus TCP/IP protocol. Before starting my presentation, I would like to thank my advisors Mehmet Uğur Soydemir and Savaş Şahin for their supports in this project. With industrial automation systems, it is possible to increase production quality, reduce costs, and save time in production. Along with the developing industrial systems, there have been needs such as monitoring, communication, and remote control of these systems. With these needs, the concept of Industry 4.0 has entered our lives. The purpose of Industry 4.0 is to bring together information technologies and industry. Communication standards and protocols such as OPC and Modbus are used to achieve this unity. This study implements a conveyor belt speed control application on the LabVIEW platform via an OPC server. In addition, with LabVIEW, the conveyor belt system can be monitored in real time, the stability of the system can be observed, and fault prediction can be made by processing the stored speed and encoder data. Let's look at the materials. In this study, Mitsubishi FX5U PLC was preferred as a controller. This is the PLC. Extremely common in industry, these controllers are highly durable and functional. Two PLCs were used in this project to show their compatibility with the factories. The outputs of the selected PLC transistor outputs, as you can see. In this way, the pulse width modulation technique can be used. If a PLC with relay output was preferred, the relay would break down after a while due to the frequency of PWM signals, because relays are mechanical elements. With this method, the motor on the conveyor belt can be controlled without the need for any motor driver. Pololu gear motor was used in this project. This motor could not be mounted directly to conveyor belt system. Therefore, a part was designed via Autodesk Inventor software and printed by a 3D printer. This is the design part. Then the motor and designed motor holder were combined and mounted on the conveyor belt system, as you can see. Now, let's look at the methods in the project. First of all, OPC and Modbus TCP/IP were preferred as communication protocol and standard. As you can see in the figure, an OPC-based system can work with many other systems, such as PLC, Modbus, SCADA, etc. PLC was communicated with LabVIEW software using the OPC server. Tags defined on OPC are used in common in PLC and LabVIEW. A change in one of these tags on the PLC or LabVIEW side affects the other one in real time. The tags in the image on the left are used to control one of the motors on the conveyor belt. As you can see, these are the tags. In the image on the right, it is seen that the communication of two PLCs over Modbus TCP/IP is successful. As for the algorithm and method that provides speed control of the motor, PID control was used to provide speed control of DC motor in the project. PID control is a control system that calculates the error value by comparing the input and output quantities of the system in a closed system and generates a new control signal by using the proportional, derivative and integral gain parameters of the system. In this formula, Kp, Kd and Ki refer to proportional, derivative and integral gain coefficients respectively. Also, Et denotes the error signal and Ut denotes the control output. The feedback signal is required for PIDs taken from the encoder on the motor. Let's move on to pulse width modulation technique. This method was chosen to drive the motor. It It generates a square wave on the basis of the PWM technique and takes the frequency as a reference. The speed of the motor determined by adjusting the duty cycle. The duty cycle calculation is shown in this formula. As for the software used in the project, GXWorks 3 and LabVIEW were used. GXWorks 3 is a PLC programming software. Mitsubishi PLCs can be programmed with this software. The program is written using the ladder diagram, which is standard in almost every PLC. The program in the image includes the encoder reading and PID algorithm part. LabVIEW is a graphical programming environment where test, validation, and control programs can be created. LabVIEW blocks such as indicator and control were used. In the picture on the left, you see the front panel of LabVIEW. You can adjust the speed from this panel, see the speed values in real time, and you can also set the KP, KD, and KI values I mentioned before the PID controller. The second picture is here, and this is control program created in LabVIEW using text created with OPC. The picture on the right shows the data storage program created on LabVIEW. With this program, the operating values of the system can be recorded. Before testing the system, the motor was mounted to the system. As seen in the pictures, the motor will move this conveyor belt. The area where the system is tested is shown. As a result of the study, it has been shown that the speed of conveyor belt system can be controlled real-time via computer. Thanks to OPC, the LabVIEW platform on the computer and the PLC were successfully communicated and the data sent via LabVIEW were processed in real time by the PLC. In addition, with the communication of two PLCs over Modbus TCP/IP, the applicability of this study to real systems has been proven by communicating with many PLCs in industry. Now I am going to show you a video of one of the tests I did during the study. When I changing the set value, motor speed is changing. Thanks for listening.